All right, this is the third and final part of our lesson on graphing rational functions. Let's zoom in on number 10. All right, I would like to find the asymptotes first, okay? If I want to find the vertical asymptotes, I need to set the denominator equal to 0 and solve. So that would be like this, x squared times x minus 2 equals 0. This is how you find vertical asymptotes. Well, using the zero product property, though, I'm going to set each one of these parts equal to 0. So I'm going to wind up doing x squared equals 0 and x minus 2 equals 0. So this is going to give me a vertical asymptote over here of just x equals 0. If you want, you can think of it as taking the square root of both sides, whatever. Over here, I'm going to add 2 to both sides, of course. So that's going to give me x equals 2. So I have two vertical asymptotes, one at 0 and one at 2. So let's go ahead and draw those vertical asymptotes now. So these are my vertical asymptotes. Now, how about the horizontal asymptote? Get rid of some of this stuff. Whoa, too much jumping around. Too much jumping. Okay, when I find the horizontal asymptotes, that's where I have to wonder about the degree. All right, so remember, if I want to know about the horizontal asymptote, it depends. If the degree of the numerator is less than the denominator, then y equals 0 is the asymptote. If the degree of the numerator is equal, then my horizontal asymptote will be y equals a over c, where a and c are leading coefficients. If the degree of the numerator is greater, then there is no horizontal asymptote. So, which situation are we in? Well, let's analyze the degree. In the top here, the degree is 0 because there are no variables up here. Down here, the degree is actually 3. All right, you have to sort of imagine doing the distributive property, but x squared times x, that's x to the third power, so that's degree 3. Anyway, the point is, the degree of the numerator is less. And we just said if the degree of the numerator is less, then y equals 0 is the asymptote, horizontal asymptote. Okay? I forgot to write down my vertical asymptote, by the way. But my horizontal asymptote is going to be y equals 0. And my vertical asymptotes were x equals 0 and x equals 2. All right, as you can see. So let's go ahead and graph our horizontal asymptote of 0. Okay, so there's the whole asymptote situation. Okay, now, so we have the asymptotes. Now let's find the x-intercepts and the y-intercepts. If I want to find the x-intercepts, what I do is I set the numerator equal to 0 and solve. Okay, if I do that, if I set the numerator equal to, whoa, wait a minute, this numerator can't be 0. Okay, so that's because there are no x-intercepts. No x-intercepts, very interesting. Okay, so even in here, there are no x-intercepts. Okay, 2 can't be 0, so there you go. Now, what else am I going to say to you? Oh yeah, let's just write that down. X-intercepts, none. Now, how about the y-intercept? If I want to find the y-intercept, then I plug in 0 for x. But I can't, because if I plug in 0 for x, I'm going to get 0 for the denominator. And you can't divide by 0. It's undefined. So, and look, we have an asymptote on the y-axis as well. So y-intercepts, none again. So we'll just have to rely on our table of values. Now be careful. We're going to need decimals to know what's going on in here. There's no way around it. You can't just use 1 because that's right in the middle. we're going to need to do 1/2 and 1.5, you know, or 0.5 and 1.5, and 1. Anyway, on the left, let's use two values. So I'm going to do -2 and -1 on the left. So, okay, -2 and -1. So we need 2 points on the left. Now, we need to see what's going on the left and the right. On the left, that's 0.5. So I'm going to do 0.5. Right in the middle of this little section, that's 1. So I would definitely do a value of 1. But then I want to know what's happening on the right as well. And so that would be 1.5. And then we need two values to the right of the asymptote. So this is 2, so let's say 3 and 4. Okay, so 3 and 4. Okay, let's put those into the, let's put the equation into the calculator and come up with a bunch of y values. All right, put the equation into your calculator and you take a look at the values, see what you got. Yeah. All right, so we got all these values that we can use. So let's see. All right, so at -2, I've got 1/8. I can toggle that by hitting this button right here and get the decimal. So -0.1. And -1, I've got 2/3, which of course is -0.7. Okay, now I'm going to switch over and remind you about ask x. So I'm going to start over by hitting table again and hitting enter. Now see right here where it says ask, let's try that out. Instead of auto, we'll do ask. Okay, so what it's waiting for is, so if I want to do 0.5, now I can just type in 0.5 and hit enter, and it immediately gives me the y value that goes with it. So toggle it, that's -5.3. Okay, so if I type in 1, I get -2. If I type in 1.5, I get this, which is -1.8. Let's see, how about 3? Okay, that's, and last but not least, 4. That is 0.1. I'm rounding, obviously. Okay, so I'm just going to plot these points and see what we got. So -2 is -0.1. So that's just barely below the line. -1 is -0.7. Okay, that's almost 1 down. 0.5 is -5.1. So here's 0.5 and -5.1 will be right here. Okay, at 1, we're at -2. Okay, so at 1, we're at -2. It's not doing it. Okay, technical difficulties. Okay, at 1.5, that's negative 1.8. Okay, so 1.5 negative 1.8. Okay, that would be like right here. Alright, I'll come back to that one. At 3, we're at 0.2. Alright, 3.2 is like right here. And at 4, we're at 0.1. So 4, we're at 0.1. Now, I'm not 100% clear what's happening here. Is it going on up towards the asymptote? Like, is it going to cross over the horizontal asymptote? Or is it going to somehow bend back down and go down? I feel like I need to explore. Let's see what happens at 1.9. That'll be interesting. 1.9. Okay, look at this crazy number. Okay, that's negative 5.5. Okay, so 1.9 is negative 5.5. Okay, so I guess that answers my question. Somewhere between here and here, it turns around and comes back down. So I hope you're watching this and seeing how I can't just give you a rule telling you how many points you need. Sometimes you need several points to show you what's going on. Since I didn't have any x-intercepts, I sort of knew that it wasn't going to go up this way, because that would cause another x-intercept in here. So I felt like it needed to turn back around, but I needed an extra point to see it happening. But now I feel like I have enough points to draw the graph. Alright, so with these points going on over here, it must be doing this type of thing. Okay, didn't really want it to come away like that. So it should look something like this if you connect all those dots. Alright, now, symmetry, clearly there is none. Alright, it doesn't have y-axis symmetry, it doesn't have rotational symmetry, it's just all out of whack. So that was number 10. I don't know what happened to the 1. Can I add it back in? There we go. Alright, one more to go. Let's do number 12 now. It's kind of complicated looking. Let's start with the asymptotes. First of all, the vertical asymptotes. How do I find vertical asymptotes? I set the denominator equal to 0 and I solve. So that means I'm doing x squared plus 2x minus 15 equals 0. Alright, we're finding vertical asymptotes right now. That's how we do it. I'll label what we're doing. Probably this is factorable, so let's shoot for that. X squared would be x times x. 15, try 3 times 5. To have a positive 2, I'd need a negative 3 and a positive 5. And that does make negative 15. A negative times a positive is a negative. Okay, so if I set these equal to 0, then I get x minus 3 equals 0 and x plus 5 equals 0. Adding 3 gives me x equals 3. Subtracting 5 gives me x equals negative 5. So these are my vertical asymptotes. X equals 3 and x equals negative 5. Okay, let's go ahead and graph those vertical lines. Okay, so there we have vertical asymptotes at negative 5 and 3. Now, let's talk about the horizontal asymptotes. All right, for the horizontal asymptote, that's where we consider the degree. Okay, so the degree of the top is 2, the numerator, and the degree of the denominator is also 2. Okay, so this is that situation where the degrees are equal. So that means that the horizontal asymptote will be y equals a over c, where a and c are the leading coefficients. Okay, so a is 3 and c is 1. Okay, so that means y equals 3 over 1, which of course is just y equals 3. So we have a horizontal asymptote at y equals 3. Okay, let's draw that. So there we go. Alright, let's talk x-intercepts. To find the x-intercepts, we set the numerator equal to 0 and solve. Okay, so that means setting this equal to 0. I'm going to go ahead and do the distributive property. So that'll be, or you know what, maybe I won't. I changed my mind. So I'm setting this equal to 0 and I'm solving. So I've got 3 times x squared plus 1, and I'm setting that equal to 0. The reason why I decided not to do the distributive property is because it would be nice to just divide by 3 right now. Okay, if I do that, then that gives me x squared plus 1 equals 0. Alright, since 0 divided by 3 is 0. However, I can already see that this is going to be imaginary, because if I subtract 1 from both sides, then that's going to give me x squared equals negative 1. If you square something, it's going to give you a positive number, unless it's 0, which would give you 0. But there's nothing I'm going to square that's going to give me negative 1. So maybe that means that there are no x-intercepts. Let's go with that for right now. X-intercepts, none. Okay, that's what I think that means. Now, for the y-intercept, we just let x be 0. That's all. So we don't really need a calculator for that. Alright, if we let x be 0, that means this is going to be 0, and this term will be 0, and this term will be 0. So that's going to give us 3 times 1 over negative 15. Okay, this is how you find the y-intercept. You let x be 0. Because the y-intercept is 0 comma something. So I'm putting in the 0, and I'm going to see what I get. So this is going to, obviously this 1, we don't need it. So it's 3 over negative 15, which is negative 1/5. Okay, so there's your y-intercept, 0 comma negative 1/5. Okay, which is the same thing as 0 comma negative 0.2, by the way. Alright, so negative 1/5, that's just a 1/5 of a square below 0. So that'd be like right there, just below the x-axis. So that's my y-intercept. Alright, now we need a bunch of points to graph. So I need at least 2 points over here. Okay, I need 2 points on the left, 2 points on the right, and 2 points over here on the far right. So let's see. So how about negative 7 and negative 6 for that zone. Okay, in this area, how about if we do, let's do negative 2 and negative 4. Should be pretty good. So negative 4, negative 2. And then we've got this, and let's just do 1 and 2. See how that goes. Alright, now for this zone over here, let's just do 4 and 5. Okay, 4 and 5. Got to add one on. Alright, that's a lot of points. Okay, now what I'm going to do is I'm not going to make you watch me put these points in one at a time. I'm going to put this equation into the table function of my calculator, and I'm going to generate the table of values. But I'm going to do that off camera, and you can just see how I did. Alright, so here I've typed it in. Okay, so I think I'll switch back to auto mode. Alright, so here I found a couple so far. Okay, so for example, -6, it was 37/3, but I hit the toggle button, I'm getting 12.3. Okay, -4. That's this toggle button. It's -7.3. Alright, so here's my entire table of values. Alright, make sure you're getting the same stuff that I'm getting. Alright, so now I'm just going to plot all of these points on the graph. I'm going to do that off camera as well. I think you know how to plot points. Alright, these are all the points from the table I just graphed. I'm noticing that one of my points is off the table. Okay, that 12.3. So that makes me wish I had picked a different point for that. So I think I might try -8 instead. Okay, because that one's so far off the table. Rather than putting it up here, I'll just stick it down here. So let's see what I get if I do -8. And I can just scroll to it. Alright, at -8, we're at 5.9. Okay, let's check that out. So -8. Okay, here's 4, here's 5, here's 5.9. Okay, so these 2 points are better than this point and this point. Alright, so these are the kind of choices you have to make to get a good view of what's going on. So all I'm going to do is try to draw a curve through these points, but hopefully you can see the idea happening here. This is sort of a wide branch over here, so I feel like it's doing maybe something generally like this, especially since I got that extra point up there sort of showing me. Now down here you see how it's bending back around, and we've got our asymptotes here, so it must be doing this type of thing. Okay, and then this is doing the same type of thing over here. Alright, so that's what's going on in there. So notice no Xintercepts, so that's why we were getting imaginary numbers. Okay, so it looks like we were right. And then these 2 points in here must be doing this type of thing. Okay, and that's it. So your graph for number 12 should look very much like this. Alright, and this is not going to have y-axis symmetry. Whoops. It's close to having y-axis symmetry, but you see how it's kind of off to the left from the y-axis. So symmetry, neither. And that is it, my friends. Okay, so you probably are beginning to understand that other than knowing the rules to come up with the asymptotes and the x-intercepts, I guess the y-intercept too, but mostly the x-intercepts, the trickiest thing is picking the right points. But the key is you have to pick enough points that you can see the shape. Alright, until you start plotting points, you're very much in the dark. We've seen graphs that come up and go across the horizontal asymptote in a situation like this and go on up. So if I only had points on the left side here, I wouldn't know if it should be going up through here. So I had to pick enough points so I can see it's curving on the left and curving on the right. So use your judgment, but the more points the better. And sometimes you'll need decimal fractional points to really see what's going on. Alright guys, I hope this was helpful to you. I will see you on the next video.